Hi guys, this is Daily Mathematics and today we have this question here: 3 raised to the power of x plus 9 raised to the power of x equals 27 raised to the power of x, and we are asked to solve for x. So from here we can see that 3 raised to the power x plus 9 here is actually 3 raised to the power 2, right? Raised to the power x, and 27 is 3 raised to the power 3, right? Also raised to the power x. And so from here we have 3 raised to the power x plus, so this is 3 raised to the power 2 raised to the power of x, and when we have a raised to the power m and it's raised to the power n, we can say a raised to the power n raised to the power m. We can do it like that, so it's still the same thing. So we can say 3 raised to the power x raised to the power of 2 equals, and we can still do the same thing for this one too, and we can say 3 raised to the power x raised to the power 3. Is that clear? So from here we have this common, 3 raised to the power x common, so we can say let 3 raised to the power x equals a or b or c, any letter you want to use for it. And so yes, and so we have a, because 3 raised to the power x is a plus a squared equals a cube. Can you see that? Let 3 raised to the power x equals a, and we have a, and we have a squared, and we have a cube, and so we have a plus a squared minus a cube equals 0. That's if we are collecting like terms. For collecting like terms, you can do it that way. And so from here we can a is common in all through this side, so we can bring out a 1 plus a minus a squared equals 0. So can you see that? So from here we can see a is equals 0, and we can see 1 plus a minus a squared is also equals 0. So a equals 0, that's gone. So from here we can see this is a quadratic equation, right? A quadratic equation. This is a quadratic equation, so we can write it as minus a squared plus a plus 1 equals 0, right? So from here we can divide all through by minus 1, that's to cancel this minus here. So from here minus cancel, so we have a squared minus and plus gives us minus, so minus a minus and plus gives us minus 1 equals 0. So if we are to use the quadratic equation formula, which is x equals to minus b plus or minus square root, right, b squared minus 4ac over 2a. If we are to use this what they call it, this formula, how do we do it? So first of all, what is a, b and c? So this is a, this is b, this is c, and it's not actually the letters, it's the coefficient of the letters. As you can see, a here, sorry, a is 1 and b is minus 1. That's the coefficient of the letters, not the letters. And c is the last one here, minus 1 also, right? So x equals minus b, so b is minus 1. So when we're talking about minus b, we have minus 1, and we have plus or minus square root b squared. B is minus 1, so we have minus 1 squared minus 4 times a is 1 times c is minus 1 over 2a. 2 times a is 1. Are you seeing that? So the next one we have to go to is from here, minus and minus gives us plus, that's 1 plus or minus. So from here we have minus 1 squared, that's 1, right? So minus 4 times 1 times minus 1. Minus 4 times 1 is minus 4. Minus 4 times minus 1 gives us plus 4 over 2 times 1 gives us 2. And so from here we have 1 plus or minus square root 1 plus 4 is 5 over 2, right? So we can see that x, right, x is equal to, or since it was a that we are given as a letter, so we can use a. So x is like, let's just use a, please. A is equal to 1 plus root 5 over 2, or 1 minus root 5 over 2, because that's what this plus or minus means. 1 plus root 5 over 2, or 1 minus root 5 over 2. And so from here, what do we have to do? So and we saw that 3 raised to the power x equals a. So from that thing we did, we said 3 raised to the power x equals a, and a equals this. So from here we can see 3 raised to the power x equals a. This a, that's 1 plus root 5 over 2. Or we can also see that 3 raised to the power x equals 1 minus root 5 over 2. We can also see that. So from here we can do log of both sides. So from here we can say log 3 root raised to the power x equals log 3 1 plus root 5 over 2. And after that, from here we can do this is raised to the power 3x. So this is 3 raised to the power x, sorry. So we can say, we can bring this x here, x log 3 equals log 3 1 plus root 5 over 2. That's for the first instance. And so let's come here, please. And so from the last one we have x, right, x log 3 in base 3, right, equals log 3 1 plus root 5 over 2. And so from here, log 3 in 3, we know if we have anything like log a, it equals 1. So log 3 in base 3 is 1. 1 times x is x equals log 3 1 plus 5 over 2. So this is the first instance of x. But for the second instance of x, second instance of x, we have 3 raised to the power x equals 1 minus root 5 over 2. So if we are still to put the log 3, so it will still actually give us the same thing out. So if we are still to put this, so log 3 raised to the power x equals 1 minus root 5 over 2. So from here we can still bring this one to this side, x log 3 in base 3 equals 1 minus root 5 over 2. And so log 3 in 3, that's 1 times x equals 1 minus root 5 over 2. So these are all the values. So these are all the values of, sorry, we'll put log in this side at both sides too, log also. So these are all the values. So x is either log, so x here is log 3 1 minus root 5 over 2. So it's either this or this. Is that taken? All right, thank you. That will be all for today. See you in our next class.